Today we're going to be talking about how to find discontinuities of a multivariable function. And in this particular video, we're going to be doing two separate problems because they're both short. The first one is the multivariable function f of xy is equal to e raised to the 1 divided by x minus y. So we're looking for discontinuities of this multivariable function, and we can also think of this as z is equal to e to the 1 over x minus y, right? Those are the same thing. We have a function for z defined in terms of two variables, x and y. And remember, we're just looking for points where this function will be discontinuous in its domain. We can kind of work our way through each of the pieces of the function. First of all, we know that the exponential function e is continuous everywhere in its domain, right? So we don't really have to worry about that part. E is continuous everywhere in its domain. 1 over x minus y, that's a different story, obviously. We have a rational function here, and we know that for a rational function, in other words, a fraction where the numerator and the denominator are both polynomial functions, we know that the denominator of a rational function can't be equal to 0, otherwise there's a discontinuity there at that point. So we can say x minus y is equal to 0, and if we solve this, we see we get x equals y. So when x equals y, 1 over x minus y is going to be discontinuous. And when that's discontinuous, e to the 1 over x minus y will be discontinuous. So this function is continuous everywhere except when x is equal to y. Now for our second function here, capital F of xy, we can also think of this as z is equal to, we have cosine of the square root of 1 plus x minus y. And in this case, we know that the cosine function is continuous everywhere, right? It's just a curve that oscillates back and forth between -1 and +1, and it's continuous everywhere. However, when we take cosine of a square root of this polynomial function, we know that 1 plus x minus y is continuous everywhere because 1 plus x minus y is a polynomial function, and we know that polynomial functions are continuous everywhere. So we don't have to worry about this function specifically. But when we put it underneath a square root sign, when we take the square root of something, we want whatever's underneath that square root sign to be greater than or equal to 0. So we have to say 1 plus x minus y is going to be greater than or equal to 0. That's the restriction that we need to put on it. But other than that, there's nothing that we have to restrict about this polynomial function specifically. There's nothing that we have to specify when it comes to the cosine function because both of those on their own are continuous everywhere. It's just that this value underneath the square root sign, because we have that square root, has to be greater than or equal to 0. And we could leave the expression this way, or we could manipulate it if we wanted to. For example, we could add y to both sides and say that 1 plus x has to be greater than or equal to y, or in other words, y has to be less than or equal to x plus 1. We could write it that way as well. But in either case, this is the only restriction. If we have y greater than, right, we have y less than or equal to x plus 1. So what that means is that when y is greater than x plus 1, or we could subtract y from both sides and say when 0 is greater than x minus y plus 1, or flip that around and say when x minus y plus 1 is less than 0, when this occurs, our function is discontinuous because we would have a negative value underneath our square root sign. And of course that makes sense because this here is exactly the expression that we have underneath the square root sign, and we don't want it to be less than 0, and here we've defined it as less than 0. So when this occurs, the function is discontinuous in the same way that when x equals y, this other function here is discontinuous. So you're just looking for points in the function where a piece of the function is undefined, and that's how you find discontinuities of a multivariable function.